What's up, everybody? It's Hutch here, and this is Module 11, Lesson 5 on angle relationships and triangles. So here's our vocabulary for this lesson. We're going to be focusing on interior and exterior angles, specifically looking at this understanding of the relationship between exterior angles and remote interior angles. So let's go ahead and jump right in and see what we're talking about here. Okay. So understand, we've already talked about that the vertex is essentially that corner where the line segments intersect. We don't use the word corner, we use the word vertex. Okay, inside the angles inside of a triangle, those are called interior, and the ones on the outside are exterior. Very similar to when we had the parallel lines with the transversals. All right, let's go ahead and practice just naming the sides of things so that we build a foundation with that. Okay, so you can see we have side xy. You could also say side yx, and that would be fine as well. Okay, so if we're looking at this next one, when we're talking about the line segment, sorry, it's line segment xy, we would have line segment. So we draw the line segment for the top, and then you just write yz or zy. Okay, and then we have line segment xz. So moving on. All right, now let's talk about vertex. A single vertex is a vertex, and multiple are vertices. So we have vertex x, we have vertex y, and we have vertex z. Plain and simple. All right, and then we know the angle symbol is written like this. So let's go ahead and name these ones with the arrows. So we have angle y, but we're going to write it with the angle symbol, like that. And then what would that one be? Obviously, angle z. Okay, not too complicated. All right, so now what I want you to do, if you can do this at home, it's great. If not, you can just visualize it, and that's fine too. We're going to take a triangle like this one here. Okay, you could draw any triangle on a piece of paper, make it look similar to this, and then you literally are going to tear it, okay, and tear it here, okay, and you end up with these three pieces of paper. I want you to take notice about these exterior angles, okay. We already know that, or sorry, the interior angles. We already know that these interior angles add up to 180 degrees because we've discussed this before. But let's go ahead and see what that looks like. So if you pull those apart and we put the three angles together, those three interior angles, you can see that when you put them together, they create this perfectly straight line. Okay, and this is the straight angle or 180 degree angle. And so that just is physical proof that the three interior angles, when you put them together, equal 180 degrees. And that's going to be true for any triangle. So let's go ahead and complete the equation for the triangle below. We have 110 right here, plus 25 degrees, plus 45 degrees. All that has to equal 180 degrees, okay, if written correctly, right? And so in words, the sum of the measures of the interior angles of a triangle equals 180 degrees, or x plus y plus z equals 180. Okay. All right, let's go ahead and just test this out. Nice and simple. You can see we have a triangle right here. Okay. And this triangle has three interior angles. We identify that this one is 90 degrees because of the little box. And so you have the equation below. Okay. Now we're going to go ahead and combine like terms, like we always should, to simplify the expression. And so we have, if we pull out our calculator, obviously it's 146, but it's always good to make sure that you are right. So we plug it in just in case. Separate your workspace here. We have x plus 146 equals 180. And now we can go ahead and subtract those two known angles. So let's go ahead and do minus 146 on both sides. Cross that out, and we're left with our final angle of 180 minus 146 equals 34 degrees. Okay, and so now we know 34 degrees plus 90 plus 56 equals 180. Okay, all right, so there we go. Go ahead and hit pause and find the value of x for this doghouse. okay? All right, x plus 86 plus 47 all equals 180 degrees, okay? That's that triangle sum theorem. So let's go ahead and solve for x. So obviously you're doing 180 minus the sum of those two, but let's go ahead and show it. So first step is going to be combine like terms. So let's go ahead and do our 86 plus 47, and we get 133. So x plus 133 equals 180, and now we can subtract 133 on both sides, and our x value is 180 minus the 133, and we have 47 degrees. So I'm going to go ahead and write it right in there. Okay. All right, let's go ahead down to example number 2. It says use ratios to find angle measurements. So they're giving you this ratio right here. Okay. And they're saying the angle or triangle ABC. So this is how you would say triangle ABC. The measures of angle ABC respectively are in this ratio of 1 to 4 to 5. So that means the first side is 1, the second side is 4 times that amount, and the third side is 5 times that original amount, okay? Or 5 times the value of 1. So let's go ahead and create our equation. You can see down here we have x, and this would be the 1. This is representing the 4 times that amount, and this is representing the 5 times that amount. And so to write it as an equation, we would write it as 1x, and then 4 times x, and 5 times x. So let's go ahead and separate your workspace and solve this out. Okay, so the first thing that we're going to do is you should see the x club here, and we're going to combine like terms. Okay, so simplify this equation first, and then we'll go from there. So we have x. Oh, do we have more x club? Yeah, we do. We have a 1x too, right? So we have a 5, 6, 7, 8, 9, and we have 10x total. So we have 10x equals 180. Okay, and then we can go ahead and divide both sides by 10. Cross that out, and we get x equals, swoop, 18. Okay, all right. And so this is a good one to just make sure you did it correctly. And so we would have, Desmos would probably be better to plug this one in, okay, because of the order of operations stuff going on here. All right, so we have 18 plus 4 times 18 plus 5 times 18. And you can see it equals 180. So we are correct, and that checks out. All right, let's go ahead and try this. They're telling you that triangle LMN is in the ratio of 1 to 2 to 5 regarding its angles. So find the measure of each angle. Okay, all right. And actually, that makes me think up here. What were they asking us here? Find the measure of each angle. So we actually have to go back up here to answer that question. We have angle A, B, and C. So angle A, so we can say the measurement of angle A is 18. The measurement of angle B equals 18 times 4. Okay, so let's just clear this. 18 times 4 is 72. And the measurement of angle C equals 18 times 5, which is 90. Okay, so there we go. Okay, and let's make sure we put our degrees in here so we don't lose a point for units, and there we go. All right, let's go ahead and do the check now officially. If you want to pause, you can, or just follow along. Okay, so we have measurement of angle L, measurement of angle M, and measurement of angle N. So I'm just sort of setting myself up so I don't forget, almost like we did on the last one. Okay, all right, now we know the ratio is a 1 to 2 to 5 ratio. So that means angle L is a 1. Okay, angle M is a 2 times x. Okay, and angle 3 is 5 times x. So we're giving angle L this mystery variable. We don't know what it is. We just know it's angle L is x, so angle M has to be 2 times that, and angle N has to be 5 times that. So now we can create our equation. And the only reason we can create our equation is because we know that the one angle plus the other angle plus the third angle all has to equal 180 degrees. So because we have this number of equaling 180, it allows us to solve for x. So let's go ahead and combine like terms. We have all the x clubbed to go ahead and combine. So 5 plus 2 plus 1 is 8x equals 180. And then we're going to isolate the variable and divide both sides by 8. And we have x equals, let's go and plug this in, 180 divided by 8. And we have 22.5. Okay, so that's just what x is. So in this case, measurement angle L we know is 22.5 degrees. Okay, so double that should be m. So let's do our 22.5 times 2, and that gets us 45 degrees. And then 5 times that is 112.5. 112.5 degrees. So there's all of our angle measurements. I would definitely want to check and make sure they add up to 180 degrees. So we have our answer plus 45 plus 22.5, and there we go, 180. All right, so we're all set with that. Now let's go ahead and explore exterior angles. Exterior angles are used a lot if you do robotics and you're coding a bot. For example, let's say that the bot is starting here and it's driving along this line, okay, and it gets to here and it needs to turn left, okay. So it's facing this way and needs to turn left. I'm not using this angle. I'm actually using this angle right here, okay? Because I need to turn that amount to get it to then face this way and go to here. And once here, I need to have it turn this amount, okay? Not this little number here, okay? And then it goes straight here, and I need it to turn this amount. So we're actually using the exterior angles a lot when you're doing robotics. And so understanding this is really important for things like that. All right. So let's go ahead and check this out. We know that these interior angles, 1, 2, and 3, all equal 180 degrees. That's something we know already. We also know that angle 4 and angle 1, that's these right here, they are, what are they? They're adjacent, but what kind of adjacent? They're supplementary, and supplementary make 180, okay? What about the measurement of angle 6 and the measurement of angle what make 180? Well, that's angle 2, right? Okay, those are sitting on a straight line and make 180, okay? All right, the measurement of angle 5 with the measurement of angle what equals 180? Angle 3, these are all supplementary, okay? All right, now, next thing I want you to see is this. It says each exterior angle has 2 remote interior angles. They are not adjacent. They're not next to it. So think of a remote control for a TV. You use a remote to control something far away. So remote means farther away. And so when we have an exterior angle, okay, like number 4 is exterior, okay, it has remote interior, and it's the ones that's not here, but it's here and here. Those are the remote interior angles, okay? And so let's go ahead and take a look at what the question says here. It says, which angles are remote interior in relation to angle 5? Okay, so if I get rid of my notes here, we're looking at angle 5. Which ones are the remote, the farther away interior angles? Well, right here and right here. So angle 1 and angle 2. Okay, go ahead and do the next one. Which angles are remote interior for angle 6? So if you have exterior angle 6, which are its remote interior? Well, right there and right there. Just not the interior right next to it. Okay, and there's a reason it's important to notice those things because there's something true about remote interior angles. So let's go ahead and see what that is right now. Okay, so I'm going to have you take a look at this image here. Okay, and I want you to add up. So here's the exterior angle, okay, of 115 degrees because it's supplementary to the 65, and those together equal 180. I want you to go ahead and add up the 60 and the 55. What's 60 plus 55? Okay, so 60 plus 55 is 115. So if we make a little note here, the 55 plus 60 equals 115. Does that look familiar? Well, yeah. That's our exterior angle over here. So what would you say is true? Okay, so let's go ahead and make a statement. Okay, the exterior angle, if you spell exterior correctly, unlike me, the exterior angle is equal to its remote interior angles. Or we should say the sum of. Okay, so the sum of its remote interior angles, because we did add those together, right? All right, so that's something really important to understand. So let's try to understand why that works, okay? One thing we know is 65 plus these two equal how much? Well, right, those equal 180 degrees, okay? And so if 65 plus those two equal 180 degrees, and 65 plus this equals 180 degrees, okay, that's why this relationship works, okay? So 65 by itself, let me get my little pointer here, 65 by itself, okay, if you add it to those, equals 180. 65 by itself, if you add it to that, equals 180, okay? So if 65 is never changing, that means that this and these have to always be the same, okay? So the exterior angle with its two remote interior angles, they equal the same thing, okay? All right, let's go ahead and use that new understanding to help solve some things now. So example 3, find exterior angle measurements. Look at what you know. You know measurement of angle 2 is 55. Always jot things down. If you can't fit it, you can like make a little dot, okay, and pull it out like that, and angle 3 is 60. Okay, and you can put the degrees or not. We're just note taking. They want us to find the measurement of angle 1, and this is an exterior angle. So all you have to notice is, hey, are those other two angles its remote interior angles? And the answer is yes. Okay, so all we have to do is that exterior, let's call it x, okay, equals the 55 plus the 60. Okay, we know that they are equal to each other, those two remote interior. Okay, so this is my exterior, and these are my remote interior. Okay, and we know they're equal to each other. So let's just go ahead and solve them out. It's a super quick solve. X equals whatever they equal to. Okay, so 60 plus 55, and we got our answer. And there we go, 115 degrees. And so that means that our exterior angle is 115 degrees. Okay, so let's go ahead and officially write that. The measurement of angle 1 equals 115 degrees. Okay, all right, let's go ahead and do the check here. So go ahead and pause, see if you can pull it off. Otherwise, you can follow along with me. All right, here's a roof frame. Just pay attention to the dark green triangle, okay, not the little gold-looking wood beams there. So let's start making some notes. Angle 2 is 25 degrees. Angle 3 is 45 degrees. Find the measure of 1. Okay, well, we see that the measure of 1, let's call that our variable, is the exterior angle. And we ask ourselves, are 2 and 3 the remote interiors? Yes, they are. They are the remote interior angles. And what do we know about them? Well, we know that the exterior is equal to the sum of the remote interiors. So we can just go ahead and set this up and write what our solution is. So 45 plus 25, and you have 70 degrees. And it's not an expression, so it's just the answer. So let's go ahead and write the official answer. Measurement of angle 1 equals 70 degrees. All right, let's go ahead and continue practicing this. We're using the exterior angles to help find some missing angle measures. Okay, so it's telling us that measurement of angle 4. So they're giving us the exterior on this one, and it is 135 degrees. Okay, they want us to find the measurement of 2 and 1. Okay, they're letting us know that angle 4 is an exterior, which we already know, and its 2 remote interior are angle 2 and angle LKM, which is angle K. Okay, so let's go ahead and take a look and solve. So this is where we start getting into puzzle mode, right? Okay, so first thing we know is this is 90, so I would always label that. Okay, we know that this is the remote exterior, and it's equal to the sum of these two. Sorry if I said remote exterior, just exterior angle, and it's equal to the sum of 90 plus mystery number, right? So we have a couple ways of solving this. You also might have thought, oh, angle 1 and 4 are on a straight line. So these are supplementary angles. So I could do 180 minus 135 to get angle 1. And then I know that angle 1 plus angle K here, which is 90, plus mystery angle, they have to add up to 180 also. So you have a couple ways of solving it. You can really go any method you want. Okay, I'm going to go ahead and stick with our remote interior angle plan here. So I know 135 equals the 90 plus angle 2, which is mystery angle. And then all I have to do is solve for x. Okay, and then we have minus 90 minus 90. So we have 135 minus 90 is 45 degrees. And so we have x equals 45 degrees. So in this case, now I can plug in the 45 degrees here, and I can solve for angle 1. And really, I have a couple ways, right? Since I know this whole thing's 180, I could do 180 minus 35. Since I know that these 3 have to add up to 180, I could do 90 plus 45 plus x equals 180. Either way, you pick what you want. This is quicker, I think, to do the supplementary angle version. So I'm just going to go ahead and do 180 minus 135 equals x. Okay. And I should probably call it y because we were calling the other angle x. Okay. So let's go ahead and shift that in variable world. All right. So here we go. Let's go ahead and do our subtraction. 180 minus 135 is, well, I guess we could have left it x, huh? Is 45 degrees. Okay. All right. And there we go. So we also know that simply because we add 90 and 45 and 45 equal 90, and 90 plus 90 is 180. So we have a couple ways of solving stuff. Let's go ahead and write the measures. So measure of angle 2 equals 45 degrees, and the measure of angle 1 equals 45 degrees. Okay. All right, let's go ahead and try it out. You can pause if you want or follow along. Measurement of angle 5 is 147, so that's all the way out here. Okay. Find the measure of 1 and 2. So we're finding those two. So let's go a different route this time. Let's tackle this one first. Okay. So I'm just going to do the 180 because these are supplementary angles. Minus 147 equals x. Okay, we know this is going to be, this is silly for them to do this one because we know this is 90 again. So because that's 90, well, you know what? No, that's not true. So 1 and 2 may not be 45 and 45, right? Because even though they look like that, we can never trust that they are. And you'll see how this plays out. Okay, so we're labeling this variable x. Let's label this one y. Okay, so here we go, 180 minus 47. And so you can see it's 133. Oops, I mistyped that. 147. I was going to say that's not 143 degrees. So 33 degrees. As you can see, it's not actually a 45-degree angle. X for this one equals 33 degrees. So let's go ahead and mark that in. 33 degrees. Now I know that 90 plus 33 plus y has to equal 180. So we can set that up. We didn't do it this way on the last one, so let's go ahead and do that. 90 plus 33 plus y, those interior angles all have to add up to 180 degrees. Okay. Or remember, we could also do 147. Okay, that's the exterior equals 90 plus y, and we could solve that way as well. Okay, lots of ways to do math. Okay, all right, let's go and bring this down. I'm going to combine like terms. So the 90 plus 33 is going to be first. So that should be 122. Sorry, I don't know why I said 122. 133. That's why you put stuff into a calculator, so when you're not paying attention. Oops. Whoa. 90 plus 33, 123. Plus y equals 180. All right, let's go ahead and isolate your variable. So we need to subtract 123 from both sides. And we have y equals 180 minus 123, and we have 57 degrees. Okay, so this spot is 57 degrees. So you can see, even though it looks like they're both 45s, sometimes things aren't drawn to scale, and so you have to trust the math, not your eyes. Okay, let's go ahead and write our official answers. The measurement of angle 1 equals 57 degrees, and the measurement of angle 2 equals 33 degrees. All right, so there we go. All right, now we're going to get into the apply, and it gets a little bit messy here, so we know that we need to slow down and focus. They're bringing back some other stuff. Take a look at this. We have parallel lines, okay, and they are intersecting with transversals, okay? So you've seen that image before, right? Okay, it just looks a little bit different, okay? So your step 1 may want to be highlighting in between those parallel lines, because then you can see there's alternate interior angles, okay, that exist. Okay, so we're looking at external angles, we're looking at maybe alternate interior angles and things like that. So we have lots of ways we could tackle this with our eyes and our thinking. So what are the measurements of angle CDE? So let's find that. We start with the letter C, go to D, and out to E. So we're talking about this spot right here, which is labeled 3y. So they want to know what that is, and they want to know what BCE is. So start at B and go to C, BCE. Okay, so they're talking about this here. So these are the two that they want to know about, is here and here. Okay, and we have to use all of our information to solve it now. Okay, so let's go ahead and tackle some things that we know to be true. Okay, all right. So let's see. I think if we know this one, okay, I'm going to sort of, let me grab my pen, let me make it bigger and go to white. I'm going to make some things disappear here for a second. Okay, and I want you to look at this. So sometimes you need to cover things up with your hand to get a little bit of clarity. Okay, so when I give you some clarity, what do you notice? What kind of angle is this right here, okay? And if you said it's an exterior angle, you're right. So here's an exterior angle. And what's true about exterior angles? They're equal to what? The two remote interior angles, which are here and in this case here, okay? So that means if they're equal to each other, I can write an equation, right? So I can say the angle 42 is plus the 2x minus 21 is equal to 3x minus 21. And that's a true statement. And if we can solve for x, then we can actually turn all those into numbers. So let's go ahead and I'm going to now take my eraser and erase all my stuff here. Okay, and let's go ahead and solve for x. Okay, so separate your workspace here. And we definitely want to simplify by combining like terms. So I have a constant and a constant. Remember, you can't jump over the equal sign and combine that. Okay, that has to officially be moved through using math. You can only combine like terms on its individual side. Okay, so let's go ahead and simplify this. We have 42 minus 21. And we get 21. So right now we have 2x plus 21 equals 3x minus 21. Now we can start moving some things around. So I'm going to go ahead and I'm going to subtract 2x from both sides. We'll get rid of that. And that leaves us with 21 equals 1x, or just x, minus 21. Okay, now we can go ahead and move that 21 over. So let's add 21 to both sides. And we end up with a final answer of x equals 42. Okay, so this is what x equals, is 42. So now we can go ahead and solve these. So let's plug in 42 to x and solve these up. Okay, so anything with an x, we can plug in the number 42. So let's go ahead and plug this in now. So 2 times 42 minus 21. So this angle is 63 degrees. So you can see the problem solving that had to happen here. It's a lot of fun. I like it a lot. 3 times 42 minus 21 is 105 degrees. So this angle is 105 degrees. So there we go. We sort of simplified this up a little bit, okay, to help us solve some other things. All right, now, what do you notice now? Okay, we do have some other options. Okay, so like I said, we have parallel lines here. We have a transversal going through. Okay, and so technically you do know that you have this right here. And what would those? Those would be alternate interior angles. And we know that they're the same. Okay, so we could go that route if we want. Okay, but I'm going to go a different route today. I just wanted you to see that. Okay, so again, I'm going to take my white. Let me make this a little bit bigger, and I want you to just see some things somewhat simplified here. Okay, so if I get rid of all this, and you just don't really see this anymore, okay, what do you notice now? We have another triangle, and we know that this spot, okay, is 105. What is this spot? Well, it's an exterior angle. Where are this angle's remote interior angles? If you said here and here, you would be correct. And what do we know is true about exterior and remote interior? They're equal. Okay, so let's go ahead and I'm just going to undo this so I don't lose all my good work. Okay, so let's go ahead and create another equation now. Okay, so we know that exterior angle 105, that was circled with way too big of a pen, okay, this angle, 105, is equal to 3y, right here, plus 2y. Okay, and now we can solve for y and get that variable taken care of. Let's combine like terms. So we know we can just write this as 105 equals 5y, and then we can solve for y. Cross that out, and we have y equals 105 divided by 5 is 21. So all the y's equal 21. So now we can plug that in and plug that in. Okay, and so double y now, we know double y is 42 degrees. And we know that triple y of 3 times 21 is 63 degrees. Okay, all right, so there we go. And did that, remember we talked about alternate interior angles? Did that end up being true? Yep, it ended up being true anyway. And so there's some good proof that what we did was good. All right, there we go. You have all of your numbers put in there. Let's go ahead and officially answer the question. So angle CDE equals 63 degrees, and measurement of angle BCE equals 105 degrees. I just was trying to find it there. So there's your answers. All right, there you go. Go ahead and try this one. They really extended those parallel lines. If you did want to look at the transversal rules with parallel, you could do that, or you could explore more of the external angles like we did in ours. So go ahead and pause if you want to try that out. Otherwise, you can follow along if you need that extra support. So we need to find FDE, DEF, and FHG. Either way, I'm just going to solve all these little things and get everything we need. So FDE, starting at F, going to D, down to E. So that means that we want to find this 2x. We need to find DEF, which is the 3x. Okay, DEF like that. And FHG, which is y. So basically everything with variables we need to solve. We need to get the 2x, the 3x, and the y. So I'm going to start off noticing this triangle right here. Okay, so you sort of have to ignore other things. And I see the external angle right here. So here's my external. Where are my remote interior? Well, they're right here and here. And what's true? They're equal to each other. Okay, so I can set up my equation, say 110 equals 2x plus 3x. Okay, and let's go ahead and solve. Okay, we can combine our like terms. Okay, the 2x and the 3x, and that equals 5x equals 110. And then we can isolate your variable by dividing both sides by 5. And we get x equals 110 divided by 5 is 22. So now we solved that x is 22. And so we need to plug that into x. I'm going to go ahead and erase my other notes here now, because I know I'm going to need that cleared up a little bit for my next work. So double 22 is 44, so we figured out this one is 44 degrees. Triple 22, 22 times 3 is 66. I should probably use a different color here, or I'll put a dot, 66 degrees. Okay, I'm going to change this to 44 degrees in black. Okay, so I figured out those two. Now we need to figure out the y. Okay, so let's go ahead and look. I see, if I look at my triangles here, I see this triangle, okay, and I see my exterior angle right here. So what do I know is true? Well, I know 110 equals y plus, and I have this other unknown here. So that doesn't really help me too much. I need to do some other thinking to get some numbers down there, okay? Because I can't have two unknowns. Blank plus blank equals 110. That doesn't really help me. So I think we are going to have to use that understanding of our parallel and our transversals, okay? So if you look, let's start using that understanding. So here's an angle right here that's 66, right? So that's to the right of this transversal. Here's the transversal going down through. Okay, so this is an interior. Where is the alternate interior? Well, on the opposite side would be right here, right? Okay, so do you see that? Maybe if you turn your iPad to the side. So I know that that is also 66 degrees. So that solves that spot. Okay, and then let's go ahead and actually look at this one. So if this is 44 and we have this transversal going down through, okay, where is its alternate interior? Well, its alternate interior is right here, okay? And so because of that, I'm actually all done. I didn't have to do any other math work because I knew those rules. And so I had alternate interior right there, okay? We also could have figured this out, right? Because this is on a straight line, and these would be supplementary. So 110 or 180 minus 110, we're only 70 off there, and so these should all add up to 180 if I add up 70 plus 66 plus 44, and there you go. So we were actually able to solve a lot of those without doing any math work, just knowing our rules given the relationships of angles and lines. Okay, so pretty cool. Let's go ahead and answer our question now. So the measurement of angle FDE equals what? So you got to go find it. FDE, that's the 44 degrees. Measurement of angle DEF, so you got to go look and be careful. DEF is 66 degrees because it goes like this. Starts at D, goes to E, and to F. And where the middle is of that, the middle angle E is what we're looking at. All right, and then the measurement of angle FHG equals, so we're looking at measurement of angle H is also 44 degrees. So there we go. Okay. All right. On to your practice and homework. You have a lot of different scenarios. Take a look at the examples if you need to go back. Find the value of x. We know those ones are nice, quick, and easy. They equal 180 degrees total. You have a ratio one. Okay. So go back up to your notes and remember how we would do that. So your first one, remember, is going to be x. Okay, and all three of those angles have to equal 180 degrees. All right, number 4, it says the knitting pattern, measurement of angle 1 is 42 degrees. Find the measurement of angle 2. So here's your external there, and you do, just so you can see, you know that that's 90 degrees. Okay, so go ahead and solve that one. 5 and 6 here, you're going to plug in your numbers that you know, use your understanding of external angles, supplementary angles, things like that to solve 5 and 6. And then 7 and 8 are our really crazy ones here. Oh, sorry, you won't see these on yours. It'll be whited out. But 7 and 8 are your responsibility. But let's take a look a little bit together and tackle this, okay, to figure some things out. Number 7, find the measurements of ADC. So we're talking ADC, so right here, and DCB. So starting at D, oops, not to B, DCB, okay? So we're trying to find this spot and this spot, okay? And you have all these other numbers and expressions and things like that to help you figure those out, okay? There are no parallel lines or anything in this, so you're going to use your understanding of triangles and things like that to help you out. For example, okay, I can look at this entire triangle and I have numbers written for every single one. And so this first equation to solve this triangle will be 43 plus 3y. Oh, I can't do this because there's an x and a y. So we're going to have to do something else here for this one. So that's something sort of new that we haven't talked about. You've never dealt with equations with multiple variables. So you're going to have to come up with some different way to tackle this so that because you have some of these variables like this, okay? So that one is going to be a little bit different because of the y's and the x's. So let's sort of think through this a little bit as we go, and maybe we can figure it out together. Okay, do they give us any other information? So we do know this right here. I think this is where it has to start off because these form a straight line. And if they form a straight line, we know these two together equal what? 180 degrees. Okay, because my problem was I was even thinking, well, if I can figure out this external angle, I know the external is equal to these two remote interiors. But what do you notice about them? There's a y and an x, so I can't do that either. So that's why I think we actually have to start off with saying that 3y plus 7 plus 3y minus 13 equals 180 degrees. So we're going to go off with this understanding that those two equal 180, and notice there's no x's, there's only y's. So I'll get you started here with this one. Okay, let's go ahead and combine like terms. So we have the y club, and then we have our constant club and constant club. So let's join those together. So we end up with 6y plus, and we have negative 13 and a positive 7. So that's a 13 minus 7. Keep the sign of the bigger number, then you'll be exact, is a negative 6. So instead of writing plus a negative 6, I'm just going to write minus 6 equals 180. Let's go ahead and start moving things around. We're using SADMERG, opposite order of operations. So we have 186 equals 6y. Divide both sides by 6, and you end up with y equals, let's go ahead and do this, 186 divided by 6 is 31. So now that we know every single y in this entire thing, okay, every single y is 31, now this can really help us out. And so I think you're going to be in a good place now to tackle this because you can plug in the number 31 to all the y's and actually turn those things into numbers, and then that can help you to solve the rest. Okay, all right, take a look at number 8. We definitely have an exterior angle, so we could see if that helps us out any. Okay, let's see what else we have here. I have 103, so I can figure out this supplementary angle. Okay, and so that's probably where you're going to start, is coming up with what this angle is here. Okay, because at that point then, right, we have this external angle here, and this external angle is going to help us to sort of move around this triangle. Okay, so this is something you can play around with, and we'll see, because we know that this external angle is actually a vertical angle with this. So this is 7x plus 3 also. Okay, so that sort of might help us out a little bit, okay, because now we know that 103, okay, is an external angle, and it's equal to this one plus this one. Okay, so let's go ahead and set up your equation. 103 equals 7x plus 3 plus 3x minus 10. So do your combining of like terms, figure out x, and tell us the measure of those angles. All right, good luck. Lots of puzzling and thinking here.